Hello, can you see me? The countdown stopped, so I'm not sure if you are listening to me. Okay, well, thanks. And can you see my presentation? Perfect. Well, thanks a lot, everyone, for being here to listen to me. Thanks especially to Danilo and to Daniel for solving the technical issues. I will present a paper of my PhD thesis that's about stabilization programs, big comprehensive policy packages intended to stop high chronic inflation, and a classification of our own to distinguish those that succeeded from those that failed, and what makes the difference between those clusters. So, why should we study inflation stabilization attempts nowadays? Inflation stabilization was a big issue down in the 70s, 80s, and 90s. Then in the new century, it was not such a big problem for emerging economies nor for advanced economies. However, in the last couple of years, we saw a lot of countries getting big, high inflations, chronic inflations again. When we look at the distribution, the number of countries with high chronic inflations, we can see that there's 20 countries in the present that had more than 20% annually in the last 2 years, the average of the last 2 years. We are much better in terms of knowledge to address this issue because in the past, some countries had this problem and most of them have solved it. So we have a lot of experience on how Brazil, Argentina, the rest of Latin America, and even other countries from the Eastern Europe, from Africa, even from Central Europe, has ended those process of high chronic inflation. However, most of the scholars, most of the papers written about high inflation and how to end it had concentrated on those famous successful cases. So I think that there's a gap in the literature when talking about what's the difference between successful programs and failed attempts. And to get to know how to design a stabilization program, stabilization plan, one of these big comprehensive policy packages, we have to know the difference between those that fail and those that succeeded in lowering inflation, so we can avoid having survivorship bias. That's what I'm going to try in this paper. The takeaway is that I'm going to find or I'm going to try to show what distinguish those programs that fail from those programs that success. But what is a stabilization program? Well, I define stabilization program as a comprehensive policy package that generally includes fiscal and monetary policies intended to break a chronic high inflation regime, defined as a country with an inflation that was in the last 2 years, in the last 24 months, above the 20% threshold. And those programs include not only fiscal and monetary policies, but also an anchor to guide the prices path. That's usually the nominal exchange rate or the monetary base, the quantity of money. And also, they include some income policies like prices or wages controls, regulations, ways in which the government itself can directly affect price formation. That's intended to break the inertia, to diminish inflation persistence, and to break the regime that is installed, that is incorporated in the contracts of the society, in the expectations of each agent. So We researched about these events, we looked for them in the previous literature, and we also looked in primary sources, such as reports, newspapers, international um, organizations such as the World Bank, the IMF, and we got an extensive list. I don't know if it's purely abarcative, but it's one of the biggest in the best of our knowledge. It's the biggest database on stabilization attempts for Latin America in this period. We concentrated on Latin America and in the period after the second internalization of capitals, and we found 47 attempts in 13 countries. We will classify them as failures, temporary stabilizations, or lasting stabilizations with a classification algorithm that I'm going to show you if I have time when I finish. We ended with 13 successful programs, lasting stabilization programs, with 8 temporary stabilization programs that lower inflation in the short run, but then are not able to keep it low for the next years, and with 27 failed attempts. So we constructed a lot of these figures that show the median of each group and a measure of dispersion. We are showing the 25th percentile and the 75th percentile. As we can see, previous to the stabilization attempt, we have here the year and a half before the launching of the program. Those countries had very high inflation. Many of them had 2 digits inflation, inflations under 200, but some of them had hyperinflations or inflations above, for example, 500%. As we intended it to happen, the green group, the lasting stabilization cluster, managed to lower inflation to the zone of 0%, and then inflation stays there for at least 5 years. The yellow group, the temporary stabilization group, achieves that that low inflation, that 0 inflation, but inflation then rebounds and get to a very high level, a level even higher than the initial number. And when looking at the failed group, the red group, we can see that only in the first 6 or 7 months the inflation goes down, but then it rebounds and they do not achieve any disinflation at all. So we are going to try to understand which element can be distinguishing them. What's the conditions, what's the policies, the international elements, and the contextual things that can lead a program to be a failure instead of being a success. We are going to hypothesize that there are 5 main reasons why a program could fail. A stabilization attempt can fail if it lacks fiscal discipline. I mean, if it does not make the fiscal adjustment needed to take inflation to 0. We can see here the primary balance when the program started. As it was expected, the lasting stabilization group, the successful ones, have a higher fiscal balance than the temporary stabilizations, and the temporary stabilizations have a higher fiscal balance than the failures. It is not only in the launching year, but also in the following 5 years. So lasting stabilizations manage to get a fiscal balance and then can keep it in the next years. A program can also fail if it has a balance of payments crisis, as the previous literature has told us, the real exchange rate tend to appreciate after the launching of a stabilization program. So to allow for a deterioration of the current account balance, that's what we can see in this figure. A country has to begin with a high balance in terms of external trade, in terms of external capital movements, so to bear this deterioration. When a country starts from a lower balance, it is not able to manage the exchange rate to bear the appreciation and ends having current account crisis, a currency crisis that ends the disinflation. A program could also fail if it has not enough initial inflation. That's kind of unintuitive, but as inertia is lower in hyperinflations, and as higher inflations could foster public's demand for stabilization, it can make politically easier to take unpleasant measures, to make policy decisions that are not that are not demanded for publics when inflation is not high enough. So we expect that a higher inflation can allow for more quick and easy stabilizations. Moreover, when there are upcoming elections, government tends to try stabilization attempts, but delaying devaluations and not doing the fiscal adjustment needed. So we can understand when elections are upcoming, governments could try more vulnerable attempts that lowers inflation in the first months, that allow them to be re-elected, but that fail just after the beginning of the next term. So when governments have more time, when they are new, they make more robust stabilization programs that are more likely to succeed. And lastly, stabilization attempts can fail if they suffer from an international price shock. When the terms of trade are lower, the confidence in the sector public debt sustainability is lower, the trade balance is lower, the flows of dollar income are lower, and that can affect the ability of the central bank to manage the nominal exchange rate. That can affect the internal prices directly and can lead a stabilization attempt to fail. We are going to test this hypothesis with an order probit approach. That is, we will assume that success star is an underlying variable that is non-observable and that allows us to classify or to categorize success without the star, that is the observable variable, in these three categories that are discrete, not continuous as success star. We will estimate those deltas that are cuts on the continuous underlying variable, and we will observe and estimate what increases or decreases the probability of being in each one of these categorizations. We will estimate these betas hat, but we will report the marginal change in probability of being in each one of these boxes. We'll say that the estimated outcome of a program will be a failure if success star is below delta 1, that the program will be categorized as temporary stabilization if success star is between those two cuts, between the deltas, and that a program is estimated to be a lasting stabilization if its success star is above the second cut, if it's above delta 2. In the x vector, we will include 4 of the 5 dimensions previously shown. I'm not going to include in this first approximation the external accounts because they are severely correlated with the terms of trade and with the fiscal balance. So I'm going to let that variable to a second estimation. In our preferred estimation, our main estimation, we're including the primary balance, the inflation, the terms of trade, and the months remaining to the next election, no matter if it's legislative or executive, and no matter if it's within a democratic or non-democratic country. As we can see, the primary balance has a big influence on the probability of being failure, temporary stabilization, or lasting stabilization, and each point that the primary balance, the fiscal balance, improves, diminishes in 9% the probability of being a failure, and increases in almost 8% the probability of being a lasting stabilization. The inflation is very important also because as the number seems small, it's highly significant, and it gets a big magnitude when talking about hyperinflations. When we multiply this small number for big differences in initial inflation, it gets very higher. And each point that terms of trade moves with respect to the previous year's average also diminishes in half percentage point the probability of being a failure, and increase in almost half percentage point the probability of being a lasting stabilization. Lastly, the months to the next election also are significant and improve when this variable diminishes, when we have a upcoming next election in few time, we increase the likelihood of being a failure and decrease the likelihood of being a lasting stabilization. We can complement this estimation with the external one, with a current account balance estimations that includes also the inflation dimension. And we can see here that increasing the current account balance increase the probability of obtaining a lasting stabilization and decrease the probability of having a failed attempt. We performed a lot of robustness checks that I can show you if some of you ask for them. When we change the primary balance that is used in a linearized form and linear interpolation in the main estimation for the annual, the calendar year primary balance, the estimation remains the same. When using the overall balance of the public sector, I mean the fiscal balance including interest payments, the estimation remains the same. When dropping those countries with dictatorships and keeping only democracies, estimation remains the same. When replacing the continuous variable of inflation for a hyperinflation dummy, it remains the same. This variable has a very large magnitude. It increases in 24 points the probability of obtaining a lasting stabilization. When changing the variable of terms of trade, it remains the same, and when changing current account balance for trade balance, it also remains the same. We can change the categorization. We perform two alternative numeric rules to test for different algorithms of categorization, and the results remain the same. And when changing the specification, clustering the red with the yellow programs against the green ones, or the yellow with the green against the failed ones, we get the same results. So what have we learned? We conclude that the success of a stabilization program is not guaranteed because there's a lot of failed attempts in the history of Latin America, that the probability of obtaining lasting success depends on the conditions, political and economic, that the country is on when the program starts, and getting a higher fiscal and or external balance at the beginning of the plan increases the probability of success. And lastly, the likelihood of obtaining a lasting success also increases with higher initial inflation, with more terms of trade, and more distance to the next election, that are variables outside the hands of the policymaker, that are not manageable, but they can be seen so to design when and how a country should do a stabilization program. So that's all. Thanks, and I open to questions. Okay, that's a good question. I will go back to my definition. I think it's been discussed if this event is or is not a stabilization program. I think that it is. I think that it lacks this kind of measures. They are using fiscal and monetary contractive policies. They are using an anchor to guide the prices path. They are doing an announcement. They are trying to change expectations, but they are not using income policies. They are not controlling any price or wages or doing any the indexation mechanism. So I think that they are not using all the tools at hand, and that's not a good idea. However, they are getting here. I mean, starting from a bad point, they are increasing rapidly the fiscal balance, and they start from above zero in this dimension. So they are in good shape. I mean, when looking at our main variables, I'm not sure if it's well designed. So I have my doubts about um, what is going to be um, the outcome, the result of this attempt. Maybe what they are what's the part where they are more concentrated is to improve these two conditions and then do a new attempt that can be successful. Many of these cases are a sequence when there's first a failed attempt that improves the condition, and then a second attempt that gets to the zero inflation. So that can be a possibility. I hope to have answered you. It's a difficult question. I don't have like a probability number estimate. Anything else? Well, thanks a lot.
Hello, Camila. You can start your presentation. Okay. Okay.
Danilo, could you please help us by adding Berenice, Paula, and Melanie also to the stage? And Carlos.
Good morning. My name is Berenice del Toro, and I'm joined by my colleagues Camila Jimenez, Melanie Hernandez, Paola Obregón, and Carlos Carrasco. We are from the University of Monterrey, and today we are excited to present our research titled The Environmental Kuznets Curve for Latin America, an analysis from economic complexity. Today's presentation is structured into 5 key sections, starting with the introduction. Well, currently, we are at a critical point where the industrial societies teeter on the brink of breaching ecosystem boundaries, leading to a mass extinction event, the first one caused by humans. In Latin America, this crisis has been exacerbated due to the strong relationship between economic activities and environmental degradation. It is crucial to study this relationship because mismanagement of natural resources can impede social progress, destabilize economic growth, and diminish income distribution within a country. Furthermore, the effects of the environmental degradation are considered a threat to people's development and their quality of life. And how it is studied. The relationship between economic growth and environmental degradation has been studied through the environmental Kuznets curve, also known as EKC, and this curve takes the shape of an inverted U and suggests that there will be a point where CO2 emissions decreases as GDP increases. Most of the literature uses GDP per capita as a measure of economic growth, but recently the study of the EKC has incorporated the measure of economic structure, the Economic Complexity Index. This metric captures the amount of productive knowledge within an economy based on the products it exports. And speaking briefly about this literature, in a study focusing on Latin America, it was found that as economic activity grows, so do CO2 emissions. However, after crossing a certain income level, emissions increase at a slower rate than GDP. This becomes possible when environmental regulations are effective, the population is more conscious, and clean energy sources are used. Existing literature has some limitations, such as the use of only one environmental degradation variable, bias derived from relying on a single data source, and limited data availability for some Latin American countries. Therefore, for our research, we employ a threshold econometric model that allows to identify breakpoints within a variable. Additionally, implementing this model serves as a guide for the timely development of public policies by locating a specific point in the threshold variable. We also integrate the ECI variable since it provides more detailed information about the study of both the factors of production, and the way in which they are combined in thousands of products. Also, we focus on studying Latin America because it is a region and with limited studies on the subject, and it is known that the regional cooperation and studies are key to coordinate national efforts in macroeconomic policies.
Okay, now going to our literature review. Air pollution and economic growth. But what is pollution? This is the presence of harmful agents damaging the natural atmospheric condition, primarily caused by companies and commerce, threatening human health, ecosystems, and production processes. Some effects of air pollution are that in 2019 it caused approximately 4.2 million premature deaths globally, with 3,080 in Latin America. It is essential to lessen the link between economic growth and pollution. This because industrial societies are close to surpassing the sustainable limits. A reconsideration of human development is needed. Economic growth should be seen as a means, not the ultimate goal, in the study of human development. This can be done with ecological transition. As I mentioned before, it's necessary to decouple economic activity from environmental degradation. This requires changes in production and consumption models that efficient resource use and produce fewer emissions. Also, it is needed to include institutional efforts and changes in population values. Ecological transition is divided into ecological technological process and ecological structural change. The first one means reducing the environmental pressure through lower intensity of raw materials or ecological footprint. The second one is increasing the share of green activities to enhance environmental efficiency. Now, environmental goodness curve. This one describes the nonlinear inverted U-shaped relationship between economic growth and environmental degradation. Initially, economic growth harms the environment, but long-term higher income leads to decreased pollution, as Bernice mentioned. Incorporation of ECI has been studied for different countries and regions. The literature proves that the nonlinear relationship between environmental degradation, economic growth, and economic complexity. Talking about the SEI Economic Complexity Index, it measures productivity capacity through the diversity of goods exported by a country. It reflects societal knowledge in production, with greater complexity enabling more productive knowledge in manufacturing. Economic Complexity Index is related to sustainability, climate change, greenhouse gas emissions, and environmentally related employment. Here are some maps created to contextualize the relationship between environmental degradation and economic performance. The time periods are aligned with the economic growth stage from the commodity boom in Latin America. About CO2 per capita, the highest is in Trinidad and Tobago, Jamaica, Mexico, and recently Chile. GDP per capita in the last period, the highest were in Trinidad and Tobago, Uruguay, and Chile, and the lowest was in Bolivia, Honduras, and Nicaragua. About the SEI, is decreasing in the region. Mexico has the highest average, whilst Brazil was also high, but saw significant declines. Overall, ECI dropped by 71% in the second period and 15% in the third one.
Moving on to our data, and to analyze the nonlinear relationship that exists between GDP per capita and air pollution through the EKC, we examined the period from 1995 to 2021 for 19 Latin American countries: Argentina, Bolivia, Brazil, Chile, Colombia, Costa Rica, Cuba, Dominican Republic, Ecuador, Guatemala, Honduras, Jamaica, Mexico, Nicaragua, Peru, Paraguay, El Salvador, Trinidad and Tobago, and Uruguay. We transformed our data into 6 periods with non-overlapping 5-year averages that will be described in the following slide. The sources we used include the World Bank, the COF Swiss Economic Institute, the Economic Complexity Observatory, and the World Bank Worldwide Governance Indicators. In this context, our empirical strategy is as follows. We use per capita carbon dioxide emissions as a dependent variable. The threshold variable is GDP per capita, which is the one we want to evaluate. The economic complexity index was used as the threshold regressor, and we also used 8 non-threshold regressors that are the constant, urban population, industry, agriculture, regulatory quality, renewable energy use, globalization index, and trade openness. Environmental degradation is measured through the dependent variable, where carbon dioxide emissions come from fossil fuel and cement combustion. Our methodology identifies unknown structural breaks in a model until no more are detected. And also, to reduce the short-term volatility that can be found in the model, we constructed a data panel following Chin and Prasad's methodology, which allows for medium-term variables analysis by pulling data for different time points from the same study group, in this case, the Latin American region. And this approach increases the sample size, resulting in a total of 114 observations. We use a threshold model based on a pool data, which is ideal for us mainly because of three things. The first one is that it is a tool in econometric analysis for identifying nonlinear relationships. The second one is that it allows identifying the relationship between variables depending on the threshold when critical levels are exceeded. And the third one is that the parameters are identified and numerically estimated. Our equation represents environmental degradation, where we estimate the dependent variable using the threshold parameters estimated with GDP per capita, identifying the threshold where these critical levels are exceeded. We also apply the non-threshold regressors and the error in the model. In methodology, two approaches will be taken. The first approach uses a baseline multivariate model with per capita CO2 emissions as a dependent variable and GDP per capita as the threshold regressor. The second approach extends this by adding the economic complexity index as another threshold regressor, while GDP per capita remains the variable identifying the threshold. Subsequently, the empirical analysis includes robustness checks using different control variables that may alter the dynamics between the variables, and we also perform multi-collinearity tests, which don't show a strong correlation in any case on the variables.
Now moving on to our results. Here we can see the different models we made with CO2 emissions as a dependent variable and GDP per capita as a regressor with breaks. Model 1 shows a positive and significant relationship between GDP and CO2 emissions identified at two different thresholds. Now, models 2 and 3 incorporate the economic complexity index, and they reveal a relationship that changes from positive to negative across the two detected thresholds, showcasing an EKC. Now, models 4 and 5 display different relationships as they start with a negative coefficient, then becoming positive and returning to negative. Although these models do not showcase an EKC, they indicate a nonlinear relationship where CO2 emissions decrease at higher income levels. Now, both GDP per capita and ECI, our threshold regressors, are significant in most cases. And moving on to our regressors without breaks, urban population, agriculture, renewable energy, and the COV globalization index exhibit a significant negative relationship with CO2 emissions, suggesting that increases in these variables can mitigate environmental degradation. Now, industry, regulatory quality, and trade show inconsistent significance and coefficients. And as for our R squared, Model 5 had the better result, explaining CO2 emissions 91.73% of the times. Now, our study is focused on validating the EKC hypothesis on Latin America, and based on our results, after reaching an income level of $10,270 per capita, economic growth benefits the environment, leading to a long-term reduction in CO2 emissions and thus validating the EKC. Now, as GDP per capita increases, emissions rise until reaching a certain development level, after which they decline. Additionally, economic complexity contributes to a long-term reduction in emissions, And other key variables that we should monitor include urban population, agricultural activity, renewable energy usage, and the COF Globalization Index, consistently showing a significant negative relationship with CO2 emissions per capita. Now, taking this into account, our final remarks would be the following. In Latin America, the strong link between economic growth and CO2 emissions highlights the need for public policies with an environmental perspective. We analyzed the relationship between GDP, ECI, and CO2 emissions from 1995 to 2021 using a pooled dataset to estimate a threshold model, and our results provide evidence that higher levels of GDP and DCI lead to lower CO2 emissions, validating the EKC for the region. Our contributions include using an econometric model less common in the literature, incorporating the ECI, and identifying critical points. Now, based on our findings, we propose the following public policy recommendations. First, we should prioritize investment in renewable energy sources, benefiting companies with a lower ecological footprint, and granting benefits to imports with a low carbon footprint or that come from a certified sustainable production process. And finally, we propose to establish an autonomous environmental institution to monitor environmental factors and increase ecological awareness, aiming to, in the long term, reduce the link between economic growth and pollution. Now, our study has several limitations. We have a temporal limitation due to the availability of the ECI and limited coverage of Latin America countries, also due to data availability, and a loss of granularity due to the pooled data that we used. Future studies could focus on developing countries, incorporate an economic growth model, and also develop a predictive growth model, develop a predictive model. Now, this is our bibliography, and that's it on our end. If you have any questions, we'd be happy to help. So, Joaquin, thank you for your question, which is which country has the most close GDP to the threshold found in the preferred regression? We don't have an analysis by country, given that we used a pooled data set, but I think the mean for GDP in the region, it is within the threshold we found. But we don't have an analysis by country due to limited data availability. If there aren't any other questions, that would be it. Thank you, everyone, for your time and your attention.
Thank you.
Thanks.
Thank you.
everyone for being here, and we will see each other in the next meetings, in the next sections.